The vectors u and v are defined by u equals 3i minus 5j and v equals minus 2i plus 7j. And the first thing then asks us to find the vector 3u minus 9v. Okay, so remember, bold vectors are, but we'll underline them. So this is 3 lots of u, so we just substitute in what u is, and then take away 9 lots of then v, which is, we've got there. So this becomes 9i minus 15j, and then plus 18i, because when I times by negative 9 becomes positive, and then minus 63j. So this then becomes 27i and minus 78j. So part 2 then, it says the vectors u and v are the position vectors of the points u and v, okay, respectively. Find the length uv. So what I find useful here often is just to draw a little sketch to show the situation we've got here. Okay, so position vectors, of course, is implying then that we have an origin, and little u takes us to the point u, and little v then takes us, vector v takes us to the point v. And we're trying to find the length of uv, okay, the actual length of it, okay. Now we can do that by literally looking at the vector uv, okay. So let's think about what the vector uv will be. So that's literally going from u to v. Now to get from u to v, of course, we can go along from here to here. So we can go u to o, and then once we're at the origin, then we can go, skip to v. So that journey takes us from u to o. It's like reversing u, so it'll be minus u, and then of course o to v then will be positive v. So essentially we end up with that sort of standard result where uv is equal to little v take away u. So if I work that out, I get v, which is minus 2i plus 7j, take away then u, which is, u is up here, so be careful because I want to take it away. So take away this 3i minus 5j, so I get minus 2i plus 7j minus 3i. The minus applies then, so that becomes a plus 5j, so I get minus 5i and then plus 12j. Okay, now that's the vector uv. I want the actual length of it, so that's taken me from u to v. The length then, remember, is just using Pythagoras, because essentially if you think about minus 5i plus 12j, if you think of it as like a coordinates thing, yeah, right, coordinate system, essentially what's going on is you're going back 5 and up 12, yeah? So you're going to negative 5 and then up to 12, and you're ending up, essentially then, if I relate it to a sort of a Cartesian system here where you're going back 5, up 12, it creates then a triangle, okay, where that distance is 5, that distance is 12, so we can use Pythagoras' theorem. I mean, you don't have to draw this, you can just go straight for it to get the magnitude, as they sometimes say, is the magnitude or the length of it just by using Pythagoras. We're going to square that side, minus 5, we're going to square the 12, and then we're going to square root it, and if you do that, it comes out to be 13. Okay. Next part then, it says, part 3, write the unit vector of uv. The unit vector of uv. So, in fact, now we're going to have to use our last answer for this, right? So, for the unit vector of uv, we need to appreciate what uv is, which is minus 5i plus 12j. Okay, but if you go back to this here and think about that vector there, okay, going back 5 up 12. So with a unit vector, what we want is to still go along that vector there, but we only want it to be of length 1, okay? Now, of course, we've worked this length out here to be 13, okay? And that's what we needed to do. We worked out the size of it using Pythagoras, but I don't want to go along, I don't want to go a length of 13. For a unit vector, I only want to go a length of 1. So what I need to do is I need to divide that line up by that length so that I only go one step. So essentially I need to divide this by 13. So the vector I've got here, to get the unit vector, yes, that vector will take me all the way to that point, but essentially I only want to go a length of 1. So what I need to do is I need to share that by the 13 steps that you're going to make there. So you've worked out the magnitude, you've worked out the length of it, so all you've got to do essentially is divide this by 13. Okay, so that you can write it that way, or you can write it as 1/13 minus 5i plus 12j. And then the last part of the question asks us to determine the angle that the vector uv makes with the x-axis. So again, the diagram really helps here. So if I do angle, say theta there, and you're just going to use SOHCAHTOA, okay? So, you know, you've got the opposite here and the adjacent here. So over A, so we're going to have tan theta is over A, so 12 over 5, and then theta then will be tan to the minus 1 of 12 over 5, so theta will equal to tan to the minus 1 of that, and we get 67.38 degrees.